Here are the answers for the section 15-6 homework. Solve using the matrix method that we learned in this lesson. So first step is to rewrite it using matrices. Write down the coefficients matrix, 1, 2, 1, 3. Then multiply by the variables matrix, and it has the letters x and y in it. And that's equal to the constants matrix, which contains 5 and 7. Now to get the matrix with x and y alone, we need to remove this coefficients matrix, which involves multiplying by its inverse. So we'll go over here on the left margin and find its inverse. It's 1 over the determinant. This is 3 minus 2, which makes 1. Switch the 3 and the 1, and change the sign on that number and on that number. When you actually multiply the 1 out front to those 4 numbers, you will get a matrix with those 4 numbers. And that's the matrix that you multiply by on the left side here and on the left side here. Now I'm not going to take the time to write that matrix in this spot, because what will happen is when it gets multiplied to this, it's going to cancel away anyway. So to save writing, I'm just going to write that we get xy on the left side of the equals. On the right side, I will take the time to write our inverse that we figured out. 3, negative 2, negative 1, and 1. And the next to it times the 5 and the 7. Now, with practice, you certainly could probably take the inverse and multiply it to the 5 over 7 mentally and get the right answer without writing them side by side. But since we're kind of just starting off with matrices in Algebra 2, it's probably helpful visually to have them very close together when you're trying to multiply. So now when we do multiply them, we will get the answer, and it will be in a 2 by 1 column matrix. So 3 times 5 is 15 plus negative 14 makes 1. Negative 1 times 5 is negative 5 plus 7, which makes 2. So our answer is the ordered pair 1, 2. Now number 2, let's do the same technique. So first we want to write this using matrices. 2, 5, 1, 2. Times the variable matrix, which contains x and y, equals the constants matrix, which contains 9 and 4. Now we want to find the inverse of that coefficients matrix. We'll do that over here in the margin. 1 over its determinant. 4 minus 5 is negative 1. Then switch these, change the sign on these. When you multiply the negative 1 out front to all 4 of those numbers, it will make negative 2, 5, 1, negative 2. And this is our inverse, which is going to get multiplied to the left side of this, and we're going to multiply it on the left side of this. When you do that, the xy will be alone. And again, I'm going to take the time to actually write out the 2 matrices side by side. Okay, now we're ready to actually multiply these. Negative 2 times 9 is negative 18, plus 5 times 4, which is 20, so that makes 2. 1 times 9 is 9, plus negative 8, and so this makes 1. The answer is the ordered pair, 2, 1. Now number 3. First step, write this using matrices. So 3, negative 4, 2, negative 3. Times, and then x and y are the 2 variables, equals, and negative 6 and negative 5 are the 2 constants. Now let's figure out what the inverse of this matrix is. So 1 over its determinant. This is negative 9 minus negative 8, which makes negative 1. And then we have the negative 3 here, the 3 here, 4 here, negative 2 here. Multiply that scalar to those 4 numbers, and here's what you get. This is the inverse of the coefficients matrix, which you're going to multiply on the left side of that matrix and on the left side of the constants matrix. So we will get xy equals, this time I'm not going to rewrite the work, I'm just going to find the answer. Because I think I can look down here and look up here and keep track of it in my head. 3 times negative 6 is negative 18 plus negative 4 times negative 5, which is 20. That makes 2. 2 times negative 6 is negative 12 plus negative 3 times negative 5, which is 15. And negative 12 plus 15 is 3. So the answer is 2, 3. Now number 4. We're going to do the same thing. So first step, write it using matrices. 5, negative 2, 2, negative 1. Our variables matrix has x and y. Our constants matrix has 1 and 0. Now let's find the inverse of the coefficient matrix. 1 over its determinant. Negative 5 minus negative 4. And that makes negative 1. Switch these numbers and change the sign here and change the sign here. Now multiply the scalar to those 4 entries. We get 1, negative 2, 2, negative 5. This is our inverse. Again, we're going to times that here and times it right in here. It's going to make xy equals, and now we'll give our answer in this column matrix. 1 times 1 is 1 plus negative 2 times 0, so that makes 1. 2 times 1 is 2 plus negative 5 times 0, so that makes 2. So our answer is 1, 2. Next, number 5. Let's rewrite it using matrices. 3, 1, 1, negative 2, and then the variables matrix, and then the constants matrix. Now let's get the inverse of the coefficients matrix. 1 over its determinant. This is negative 6 take away 1, which is negative 7. Put the negative 2 here and the 3 here. Change this to negative 1, change this to negative 1. Now multiply the scalar to all 4 entries. So we have 2 sevenths, 1 seventh, 1 seventh, and negative 3 sevenths. This is our inverse. When you multiply that on the left side, it cancels away this, getting the xy alone. And when you multiply that inverse right here on the left side of this, we're going to get a column matrix. 2 sevenths times 1 is 2 sevenths. 1 seventh times negative 2 is negative 2 sevenths, and those make 0. 1 seventh times 1 is 1 seventh. Negative 3 sevenths times negative 2 is positive 6 sevenths, and 1 seventh and 6 sevenths is 7 sevenths, which reduces to 1. So the answer is 0, 1. Now number 6. Let's make our matrix equation. 2, negative 3, 3, 2. Now the variables, x and y. Now the constants, negative 7 and negative 4. And we'll find the inverse of this coefficients matrix. 1 over its determinant. This is 4 minus negative 9. 4 minus negative 9 is 13. 2 here, 2 here, 3 here, negative 3 here. And I'll distribute that scalar to all 4 entries. 2 thirteenths, 3 thirteenths, negative 3 thirteenths, and 2 thirteenths. This matrix is the inverse of the coefficient matrix. So when you multiply them together, it makes the identity matrix, which is kind of like when you make a 1 with real numbers. And so the x and y are alone. On the right side, let's get our answer. 2/13 times -7 is -14/13 plus 3/13 times -4 is -12/13. When you add these, it's -26/13, which reduces to -2. I'm writing this down because these fractions are a little tough for me to keep track of in my head. Now let's work on the answer in the second row. So -3/13 times -7 is 21/13 plus 2/13 times -4 is -8/13. And 21 and -8 is 13/13, which reduces to 1. And so the answer is -2, 1. Now, number 7. We can start right away and make a matrix equation. But it's helpful to kind of examine the thing first. Because if you notice something, if you notice it's a special case, you can save yourself a lot of time. I noticed that the second equation is a multiple of the first equation. 2 times x is 2x, 2 times 2y is 4y, 2 times 3 is 6. When the second equation is a multiple of the first, it's a special case, where if you graph the lines, they're coincident. They line up on each other for their entire length. So this has many solutions. If we made the matrix equation, when we get to the step of finding the inverse, we're going to get a determinant of 0, which means there is no inverse. Now number 8. Okay, this time, before we make the matrix equation, let's again examine what's going on here. On the left side, these are multiples of the first equation. 2x times 2 is 4x, and 2 times 2x is 4x, and 2 times the -3y is the -6y. But on the right side, 9 is not 2 times 7. So we have another special case. These are parallel lines. And so if we went through the process, we're going to find out that there's no solution anyway. Now number 9. This time I don't notice any special cases where the one equation looks like a multiple of the first. So let's make our matrix equation. 3, 5, 2, -3. And now the variables are still x and y. And the constants are 35 and -2. Let's get the inverse of this. So we have 1 over the determinant. This is -9 on this diagonal minus 10 on that diagonal. -9 minus 10 is -19. Put the -3 and the +3 there. Switch this to -5, switch this to -2. And distribute that scalar to all 4 entries. So we have 3/19, 5/19, 2/19, and -3/19. And this is the inverse that gets multiplied in this position and in this position. So we're going to get xy equals, and now a column matrix that has our 2 answers. Okay, let's do the multiplication. 3/19 times 35 is 105/19 plus 5/19 times -2 is -10/19. When you add these together, it's 95/19. Now, does 95/19 reduce? And it does. That just makes 5. So instead of writing 95/19, I'm just going to put 5 there. Now let's work on the second row answer. 2/19 times 35 is 70/19 plus -3/19 times -2 is 6/19. And when you add these together, that makes 76/19. But does that reduce to something nice? It does. 76 divided by 19 is just 4. And so our answer is 5, 4. Finally, number 10. Let's do a quick check to make sure we're not a special case, and it's not. So now let's do the matrix equation technique. So 2, -3, 2, 3. Then x and y equals, and then -20 and 40. Now let's get the inverse of that coefficients matrix. 1 over, this is 6 minus -6. 6 minus -6 is 12. 3, 2, 3, -2. And now let's distribute the scalar. So we get 3/12, which reduces to a fourth, 3/12, which is 1/4, -2/12, which is -1/6, and 2/12, which is 1/6. So here's our inverse that gets multiplied on the left side and right here. So we get xy equals, and now we're going to get our answers for x and y in here. So 1/4 times -20 makes -5, plus 1/4 times 40 makes 10. And when you add that up, that makes 5. Now, -1/6 times -20 makes 26, which reduces to 10/3. Plus, and now 1/6 times 40 makes 46, which reduces to 20/3. Adding these together, that makes 30/3, which is equal to just 10. And so our ordered pair is 5, 10.